In this lesson, you'll learn how to solve quadratic equations by completing the square. I'm going to step back a second and remember how to square a binomial. When we square something, we're taking it times itself, and we can FOIL. So we've got x squared plus 7x and plus 7x again plus 49. When we add our like terms, which always happen to be the same thing, we have x squared plus 14x plus 49. So in the process of completing the square, we don't know the constant term. But you can see here that if we take the coefficient of x divided by 2, we get one of those two 7s, and when we square that, we get our constant. The square root property can only be used to solve quadratic equations when the side containing the quadratic expression is a perfect square. However, few quadratic expressions are perfect squares. To make a quadratic expression a perfect square, a method called completing the square may be used. In a perfect square trinomial, there is a relationship between the coefficient of the linear term and the constant term. To complete the square for any quadratic expression in the form x squared plus bx, we're going to find 1/2 of b, in this case 1/2 of 14 was 7. Square the result in step 1, so 7 squared is 49. And then to finish completing the square, you're going to add that to your x squared plus bx. And the result, mine would have been x plus 7, is x plus whatever our b over 2 was, squared. Find the value of c that makes x squared plus 16x plus c a perfect square, then write the trinomial as a perfect square. So we're going to take the coefficient of x, divide it by 2, and square it. 16 divided by 2 is 8. 8 squared is 64. So there's the first answer, c equals 64. And then if we write it as a perfect square, it would be x plus 8 squared. And that'll be a step in the process that we use to solve an equation by completing the square. I can see right away that that negative 12 is not going to make a perfect square, so I just added 12 to both sides to get it out of the way. So to figure out what I need to complete the square, I'm going to take the coefficient of x divided by 2 and square it. So I can add 4 to both sides of the equation. And I'm going to point out right now from the very beginning, in the middle of the first problem we're ever doing about this, that a lot of people forget to add it to both sides and then just add it to one side. It seems silly, but it happens. Okay, so now we have a perfect square. It would be x plus 2 squared. How do I know it's 2? Because this was a 2. Equals 16. And now conveniently, that's a perfect square as well, so I can take the square root of both sides. So I have x plus 2 equals plus or minus 4. And I can subtract 2 from both sides of the equation. I have x equals negative 2 plus or minus 4. Negative 2 plus 4 is 2, and negative 2 minus 4 is negative 6. And as always, it's a good idea to substitute back into the original equation and make sure it works. 4 plus 8 is 12, minus 12 is 0, and negative 6 times negative 6 is 36, minus 24 is 12, minus 12 is 0. So our check step works. We are happy with our two answers. The next problem adds one more step. When the coefficient of the quadratic term is not 1, you must first divide the equation by that coefficient before completing the square. And this problem adds a step to the last one. I don't like the 3, so I'm going to divide both sides of the equation by 3. So now I have x squared minus 2/3 x plus something equals, and I'm going to go ahead and add that 1/3 to the other side. Now this time, instead of dividing my coefficient of x by 2, since it's a fraction, I multiplied by 1/2. So now I've got negative 1/3 squared is 1/9. So that's what I want to add to both sides of the equation to complete the square. So now my perfect square is x minus 1/3 squared equals 3/9 plus 1/9 would be 4/9. And conveniently, again, they've given us a perfect square on each side. So now I have x minus 1/3 equals plus or minus 2/3. So when we add 1/3 to both sides, we're going to have 1/3 plus or minus 2/3. And of course, 1/3 plus 2/3 is 3/3, aka 1. And 1/3 minus 2/3 is negative 1/3. I'm not going to show you the check step this time because I trust that seeing it once, you could substitute it in, use your calculator, and make sure that it works. Now, when we came across square roots of negatives in Algebra 1, we'd say, oh, not a real number, and stop there. But now you know how to work with complex numbers, so some of our answers are going to end up in that form. We took the coefficient of x times a half or divided by 2, whichever floats your boat, squared it, and we get 1 that we need to add to both sides of the equation. So my perfect square is x plus 1, and I've got equals negative 2. So when I take the square to both sides, I have x plus 1 equals plus or minus square root of 2i. And I subtract 1 from both sides. And actually, this is kind of a nice thing for you because we cannot combine, so we are done. Now, again, I tend to write it in that order. This book likes to put the I first so someone can't be sloppy and put a square root over an I, which wouldn't make sense. There's no really great way to do a check step since it's imaginary. I guess you could, but it'd be a lot of work. You'd have to use FOIL them out, So I typed this in GeoGebra, and what do you know? The parabola will never cross the x-axis. To complete the square for any quadratic expression, x squared plus bx, find 1/2 of b, the coefficient of x, square the result in step 1, and add the result to step 2.